Welcome to this video lecture. In this video lecture, I'll be discussing about a problem on force voltage analogy. So let us consider this problem statement. For the mechanical system shown below, draw force voltage analogous electrical network along with equations. For this particular mechanical system which is shown on your screen, they have asked us to draw force voltage analogous electrical network along with equations. If we observe, we have two mass elements, mass M1 and mass M2. Mass M1 and mass M2, between mass M1 and mass M2, we have K1 and B2. Between M2 and rigid support, we have K2 and B3. Between M1 and rigid support, we have B1 and K3. And a force is applied on mass M1. So with respect to this particular mechanical system, we can come to a conclusion that there are only two displacements, and those two displacements are because of mass elements M1 and M2. The displacement with respect to mass M1 is x1, and let us consider the displacement with respect to mass M2 is x2. We don't have any other special displacements because if we observe B1 and K3, one end of B1 and K3 is connected to mass M1, the other end is connected to rigid support. So this B1 and K3 is completely dependent upon the displacement of mass M1. Similarly, K2 and B3, one end is connected to mass M2, the other end is connected to rigid support. So the displacement of K2 and B3 is completely dependent upon the displacement of mass M2. Whereas K1 and B2 is between M1 and M2, that is between displacements x1 and x2. So there are no other extra displacements apart from displacements because of these mass elements. The same thing is being written over here. We have displacement x1 with respect to mass m1, which is in the direction of force F. We have displacement x2 with respect to mass m2, again which is in the direction of force F. Whereas we don't have any other displacements because B1 K3, one end is connected to M1, the other end is connected to rigid support. So special displacement is not there for B1 and K3. The same thing is applicable for K2 and B3 because one end is connected to rigid support, the other end is connected to M2, which is in turn with respect to the displacement x2. Hence, K2 and B3 doesn't have any other special displacement. K1 and B2, anyhow, it is already connected between the displacements x1 and x2. So in our problem, there are only two displacements, x1 and x2, with respect to mass elements M1 and M2. Using this, we can write equivalent mechanical system. To draw equivalent mechanical system, first we need to consider the two displacements. Here, the two displacements are x1 and x2. And the second important thing which we have to note while we are drawing equivalent mechanical system is all the elements will be connected in parallel, as shown here. If we observe, x1 and x2 are the two displacements we have. Hence, we have written two nodes, x1 and x2. Next important thing is we have to identify the elements which are under the influence of the displacements. If we observe, we have displacement x1. Mass m1 is completely under the influence of x1. K3 as well as B1 is also completely under the influence of x1. Hence, M1, K3 and B1 are completely under the influence of x1. Similarly, if we consider x2, mass element M2, K2 and B3 are completely under the influence of x2 because M2 anyhow is under the influence of x2. K2 and B3, one end is connected to rigid support, the other end is connected to M2, which is under the influence of x2. So this K2 and B3 displacement is completely dependent upon x2. So with respect to displacement x2, M2, K2 and B3 are completely under the influence of x2. Whereas K1 and B2, if we observe, it is between displacements x1 and x2. Hence, K1 and B2 is under the influence of both x1 as well as x2. The same thing is being written out here. We have a force which is acting on the system on M1, which is with respect to displacement x1. So we have written the force acting towards a node x1. with respect to displacement x1, mass m1, b1 as well as k3 is completely under the influence of x1. Hence, m1, k3 and b1 is completely under the influence of x1. One end is connected to x1, the other end is connected to rigid support. If you observe, m1, k3 and b1 are connected in parallel. Always the elements are connected in parallel when we are drawing the equivalent mechanical system. Similarly, if we observe x2, displacement x2, mass m2, k2 and b3 are completely under the influence of displacement x2. The same thing is written here. m2, k2 and b3, one end is connected to x2, the other end is connected to rigid support. So these three elements are completely under the influence of displacement x2, which are in turn connected in parallel. If we observe, spring k1 and damper b2 is between displacements x1 and x2. Hence, these two should be written between x1 and x2, and again these two should be connected in parallel. The same thing is done. K1 and b2, one end is connected to x1, the other end is connected to x2, which are in turn connected in parallel. So this is how we write the equivalent mechanical system. After writing the equivalent mechanical system, we will write the equilibrium equations. So with respect to equilibrium equations, we have to identify the nodes which we have, the displacements which we have. We have two displacements, x1 and x2. So if we have two displacements, definitely there will be two nodes. If there are two nodes, definitely there will be two equilibrium equations. If there are three nodes, there will be three equilibrium equations. If there are n nodes, there will be n number of equilibrium equations. So let us apply equilibrium equation for this node x1. To write down the equation with respect to node x1, we use Newton's law of force. According to Newton's law, the total force acting on a system is equal to the summation of individual forces. That is, the total force F which is acting on node x1 is equal to the force because of this mass, the force because of this spring, force because of this damper, force because of this K1 spring, force because of damper B2. The total force acting on a system is equal to summation of individual forces. So if we consider at node x1, we'll write down the equations. The force acting on a mass is proportional to its acceleration. The force acting on the force because of the friction is proportional to the velocity of the mass. The force on spring is proportional to the displacement of mass. So we have to keep that in mind. Acceleration formula is d square x by dt square. Velocity formula is dx by dt. Displacement anyhow is x. As I told you, the total force F is equal to summation of individual forces. Force because of mass m1, force because of damper b1, force because of spring k3, force because of spring k1, force because of damper b2. As I told you, force on mass is proportional to its acceleration. F is equal to m into a. Here m is m1. So m1 into a is nothing but acceleration. We already know the formula for acceleration, d square x by dt square. Because we have displacement x1, it will be written as d square x1 by dt square. Hence, m1 into d square x1 by dt square plus the force because of the damper of friction is proportional to velocity of the mass element. Force is equal to b into v, where v is nothing but velocity. B is nothing but damper coefficient. The damper coefficient which we have here is b1. So b1 into velocity. The formula for velocity is dx by dt. Here, because we have displacement x1, it will be dx1 by dt plus the force on the spring is proportional to its displacement. Displacement means k into x. Here the spring constant is k3, so we have written k3, and the displacement here is x1, hence we have written x1 plus this k1 is under the influence of both x1 as well as x2. Hence, we will write the equation as k1 into x1 minus x2 plus the force because of this damper b2 is proportional to velocity of x1, the velocity of mass which we have considered. Hence, the equation will be b2 into dx1 by dt minus dx2 by dt, which is the velocity with respect to mass element m1 and velocity with respect to mass element m2. So this will be the first equation with respect to node x1. Similarly, we have one more node called as node x2. At node x2, if we apply the equilibrium equation, we will get, if we observe, we don't have any direct applied force acting on this node x2. Hence, the left hand side will be equal to 0. 0 is equal to m2 into d square x2 by dt square plus d3 into dx2 by dt plus k2 into x2 plus k1 into x2 minus x1 plus b2 into dx2 by dt minus dx1 by dt. The same thing is written here. So this is how we write the equilibrium equation for the second node. Now, after writing this equilibrium equation, we have to convert these equations into our electrical analogy using FV, force voltage analogy. In force voltage analogy, from the derivation, we already know this. Mass is analogous to inductance. The damper coefficient is analogous to resistance. The spring constant is analogous to inverse of capacitance. Velocity dx by dt is analogous to current. The displacement x is analogous to integration of I dt. Acceleration d square x by dt square is analogous to di by dt. Now we'll apply that here. Let us consider this equation. This is the equilibrium equation which we have got. In place of force, we will replace it with voltage. In place of mass m1, we'll replace it as L1. In place of d square x1 by dt square, because acceleration is analogous to di by dt, d square x1 by dt square is equivalent to di1 by dt. In place of b1, we will replace as r1. dx1 by dt is analogous to i1 plus. In place of k3, we'll replace it as 1 by c3 because the spring constant is analogous to inverse of capacitance. x1 is analogous to integration of I dt. So x1 will be analogous to integration of I1 into dt plus 1 by c1 integration of I1 minus I2 into dt plus, in place of b2 will write it as r2. dx1 by dt is analogous to I1. dx2 by dt is analogous to I2. What we have done is we have applied this table, whatever we have written here, analogy, whatever we have derived, that we have applied over here. Similarly, we'll do for the second equation. With respect to second equation, 0, it will be as it is, 0 is equal to L2 into di2 by dt plus R2 into I2 plus 1 by C2 integration of I2 dt plus 1 by C1 integration of I2 minus I1 dt plus R2 into I2 minus I1. So this will be our equation number 4. So what we have done is, for this equation number 2, we have applied the conditions of FV analogy. So we have got these two equations. After getting the equations, we have to write the analogous circuit, force voltage analogous circuit that is asked in the problem. So in force voltage analogy, one important thing which we have to notice, if we observe the diagram, if we observe the main diagram here, the force acting on these elements are different. Different forces are acting on different elements. With respect to mass m1, different forces acting. With respect to b1, k3, different forces acting. So if forces are different, if we consider force voltage analogy, the voltages should also be different. The voltages will be different only in series circuit. We already know that. In electrical analogy, the voltages will be different in series circuit. When the circuit elements are connected in series, the voltages will be different, whereas current will be same. Hence, when we are drawing FV analogous circuit, all the circuit elements should be connected in series. We have to remember that. To draw the circuit, we already know that in FV analogy, elements are connected in series. I already told you the explanation why it is that. There are two masses in our problem, hence there are two meshes. The elements connected between the two masses are connected as common elements between the two meshes. The circuit looks somewhat similar to this. L1, R1, C3 are the elements which are completely under the influence of mesh M1. L2, R3 and C2 are completely with respect to mesh M2, whereas C1 and R2 are completely between mesh M1 and M2 because they are the common elements. And instead of force, we will be representing it as voltage. So this is how we draw the force voltage analogous network. One thing which we have to remember here is the elements will be connected in series. So with respect to these equations, whatever we have drawn, whatever we have got here, same equations are written in circuit form. All the circuit elements are connected in series over here. And the common elements will be written between mesh M1 as well as mesh M2. I hope that you have understood this video lecture. Thank you.